All right, so we're going to talk about truth tables and equivalent statements today, and the majority of what we're going to be looking at is truth tables. So let's take a look at the first consideration. So everything that we're looking at today are ways of combining statements. So we talked about them sort of in language form last time. Remember, we talked about conjunctions and disjunctions, but we didn't use those words maybe. So we talked about ways to combine statements using words like and or, and if then. Nod your head if you remember what I'm talking about. Yes. And as I'm thinking about it, I'm pretty sure we actually called them conjunctions and disjunctions, though you may not remember that we did very much with them because we didn't. But we're going to start with conjunctions first. So a conjunction is an and statement. So this says P and Q. And the symbol, again, we did this last time too, is an upside down V. Do you remember that? Okay. So this statement is true when both statements are true. So I want to show you what a truth table looks like for this. So when you create your truth table, you need 3 columns, I guess you'd say. One column is for the statement P, one column is for the statement Q, and your third column is for the statement P and Q. All right, so one option is that if I come in, so I'm going to give you an example, and we're going to pretend with this so that we can kind of talk about why this makes sense. So let's say that I come in and I say, I'm a teacher and I'm a mom. Okay, so there's 2 statements, right? One statement said I'm a teacher, and one statement said I'm a mom, and I put the word and between them. So this is a conjunction. Everybody following with me so far? Okay, so one option is that the person walking in saying that is in fact a teacher and is in fact a mom, i.e. me. I walked in and I said to you, I'm a teacher and I'm a mom. And you would say, yes, you are, because each of those statements are true, right? So this is a true statement when I put the word and between them, because I am a teacher and I am a mom. Okay? All right, so let's say then that one of you walks in. So I'm going to pick on Hillary today. Hillary walks in, and Hillary says, that was not a good example. Let me try again. Do we have anybody in here who's a mom? Any women? Your dad? Okay, well, I'm going to use you in a minute then. We'll get you in a second. All right, nobody in here? Okay, so, okay, let's just use my colleague, Dr. Marsh. She'll work for the moment. Okay, so Dr. Marsh teaches math with me over in the math department, and she teaches math, obviously, because I just told you that, right? She didn't have any kids. At least not yet. So, she walks in, and if she walks in and she says, I'm a teacher and I'm a mom, then that would not be true. So she is a teacher, so it is true that she's a teacher, but it is false that she's a mom. So if she made the statement, I'm a teacher and I'm a mom, that would not be a true statement, would it? No, that is not true, because she's not both of those statements. Okay, so we're going to use my sister now as an example. We're just going to go with what I was thinking to use anyway. My sister, she walks in. My sister is a dental hygienist. She is not a teacher, okay? So, F. That was my teacher sort of statement, right? She is not a teacher. She is a mom. She has 3 children. Okay, so it is true that she is a mom. If she walks in here today and she says to you, I'm a teacher and I'm a mom, that is also a false statement, because she's not both of them. All right. Then let's come down here to the last one. So do you guys know Dr. Whitlock, as in the president of the university? He's not a teacher, right? No, not a teacher. He's an administrator. Is he a mom? No, he is a dad, but he's not a mom, so this would be a false statement as well. So if he walks in and he tells you, I'm a teacher, I'm a mom, you might kind of chuckle, but then you would say, no, you're not, right? That's false. So what you're seeing here is you're seeing that this is exactly what this says. This is true when both statements are true. Hints, right there, right? It's true when both statements are true, but if either of the individual statements were false, then an and statement falls apart and it's false. You guys know this from language, right? And this is just language, and this is putting a chart to the language that you know. Okay? Now, we're going to do another one, but it's a disjunction. Do you remember what disjunctions were? From last time? You remember the symbol, don't you? Okay, so the symbol looked like this, right? Tyler was telling me. It is the word or, right? So this is the statement P or Q. And there's a couple of ways I could write this. I'm going to write down one of them. We could say that this is true when either statement and I'm going to put in parentheses, or both of them, because that's fine too, are true. So let's think again about the same P and Q that I made up before. So one option is that I come in and I am in fact a teacher, and I am in fact a mom, and if I make the statement to you, I'm a teacher or I'm a mom, that's true. I mean, I happen to be both of them, but it's true that I am a teacher or I am a mom. I just sort of happen to have overkilled the statement, right? I'm overkill, but it's still true. Now, if Dr. Marsh walks in and she is a teacher, which she is, and she says she is a teacher or she is a mom, and she is not a mom, is it true or is it false? That's still true, because one component of what she said with the word or makes the statement true. All right? Now we have my sister. She walks in and she says, I'm a teacher or I'm a mom, and she's not a teacher. She is a mom. And so if she walks in and she says, I'm a teacher or I'm a mom, is it true? Yes, it's true, because one of the statements was true. But be all that as it may, if President Whitlock walks in and he says, I'm a teacher or I am a mom, it is still false, right? Because he's not a teacher and he's not a mom. So it still cannot be a true statement if neither of the individual statements were true to begin with. Now here's what I want you to see from creating these truth tables, and you'll be able to see it a little bit better on your paper than I'll be able to show you by flipping back and forth. But take a look at the column P. What do you notice in both of your column P's? Yeah, it goes TT and then FF, right? And then what happens in column Q? TF, TF. They oscillate, right? And they match between the two diagrams, right? That is the pattern you're going to use for every truth table with two P and Q statements. Okay? You're going to always go TT, FF, TF, TF. So no matter what else happens, you can start the argument. This is like geometry. And your teacher said, I don't care if you can solve the proof or not. Well, they didn't say I don't care. But they said no matter whether you can prove something or not, you can always write down what information? Do you remember it? The given, what you know, right? You can always write down what you know. This is the what you know. You can always write down TT, FF, TF, TF. Are we good on that? So you can always start a truth table. Even if you can't finish it, you can always start it. Now, we're going to do some examples of some truth statements. Now, this is a little different. This, they actually tell you what the P and the Q are. That is, they tell you the truth value that they hold. They tell you that P is a false statement, and Q is a true statement. And they want you to find the truth value of some other joining of statements together. So the first thing that they notice, and this isn't a very exciting one, so I'm not going to even bother probably with too much of a truth table per se with this, but if P is false, what is tilde P?
True.
Not false, which would be true. You gotcha. So this is true. Okay, there's really nothing to show with that, but there is, have no fear, we're going to show lots on number 2. Okay, so taking a look at number 2, there's plenty we can show on number 2. And I'm going to show you how we show that. So the first thing that we do is we notice we've got some parentheses. And somewhere somebody way back when in an algebra course or a pre-algebra course told you that when there's parentheses, you always do what's inside the parentheses first. Right? Yeah. And you still do here. Okay? So here's what we're going to do. We're going to create a chart. Our chart is going to have one column for P, one column for Q, just like the truth tables we did before, okay? And then if you look inside the parentheses, the next thing that we do is we join those two P and Q's with the AND statement. So we're going to have a column for P and Q. And then we're going to have a column, again, moving from inside out, we're going to have a column that's the tilde of that. So tilde of P and Q. But they told you what P was. What was P? False. So we're just going to write false in there because that's the only, we don't have to do a whole truth table. They told us what P was. P was false. So it's kind of like I'm doing this one-liner, right? I'm doing the one-line truth table because I was given more information at the beginning of this particular problem. What did they tell me about Q? It's true. Now here's where you have to think back on those two truth tables we've created before. This is an and or an or statement. It's an and statement. So if I have one component that's false and one component that's true, and I join them with the word and, it's a false statement. So I write F right here. P and Q combined together is false. Okay. Now the last column is to negate that, which turns it into true. You got it. Now, you're not quite done. This is the show the work part. The answer is the answer part. That is, after the show the work part, you found out, it's not showing up, but it will there, that the answer here is true. Because it said, find the truth value, didn't it? Okay, so are there other ways to work out these problems? Yes. This is the way I want you to work it out. This is what your book is modeling, and it's what I'm modeling for you. I expect to see a one-line truth table when you're working these out, okay? And I expect to see at the end you tell me the answer. That is, my answer is true, not just here's the work, and then let me see if I can not write anything down, and maybe she'll give me credit anyway. Okay? I want to see what you know what the answer is that you achieved by doing that. All right, so we're going to do another one. But what do you notice is different about this particular one? I have three component statements, don't I? P, Q, and R. Now, for finding a truth value, it doesn't change a whole lot of what we're going to do. It's just going to create a bigger table. I definitely need a table that has a P in it, a Q in it, and an R in it, because those are the three individual statements in the problem. Now what? What do I look at and do next? The parentheses. I do the part in parentheses. So I'm going to do the QVR, right? Because that is the part that's in parentheses. Oops. Keep the pattern. Well, what's next? Yes, and it'll be joined with the part we just did. So we get the entire statement. This is my last column in my truth table now. P and QVR. And they give you some information at the front, again, just like on the last problem. What is P? True or false? True. What is Q? False. What is R? False. You should be able to do all of that. That's the given information, right? And you should be able to set up all these column headers. Even if you get confused in the last two components, you should get this far. We haven't done anything different. We've used the information they gave us, and we've set up the three columns for P, Q, and R. Okay? Now we've got QVR. So we look at the Q column, the second column, and the R column, which both are F's, right? And if we join a statement with the or conjunctive or disjunctive, is it false or is it true? It's false. Two false statements gives us a false statement, right? This is the example of President Whitlock walking in and saying, what did I say? I'm a teacher or I'm a mom. It's false because every component part of that was false already. Okay? Now, over here, this last statement here is saying that I want to join P, which was over here, right? And I want to join the QVR. So I've got a T and I've got an F. And I want to join them with the or conjunctive. I'm sorry, the and. I've got an and symbol there, sorry. The and conjunctive. So I've got a true statement and I've got a false statement. If I put an and between them, is that statement going to be true or false? It is false. An and statement needs both statements to be true. That tells me that my answer is false. false, and I expect to see you write that out. The truth value, the answer to my problem then is false. So you might be wondering how that relates when we looked at constructing truth tables, because when we did a truth table, we only had two statements, P and Q, right? So what would happen if I had to do a whole truth table for that last one and not just the truth value? Well, I'll have more rows is what I'll have. So it works something like this. If n is our number of statements, then 2 raised to the nth power is the number of rows in the truth table. Do you remember where you saw 2 to the n before this semester? It was on your test we just did, though, wasn't it, Nicole?
Yep.
We saw that expression 2 to the n when we did...
So figuring out the number of subsets.
There you go, good job. Figuring out the number of subsets. Remember, we did the number of subsets? So this is a familiar operation for us. Now, taking a look here on number 4, what I want you to realize, though, is how many statements are on number 4? Somebody said it. There's just 2, right? Statement. I know there's 3 letters, but 2 of the letters are the same, okay? The number of statements is the number of distinct letters. So just because there's 3 of them there doesn't mean I have 3 statements, okay? So I really do just have 2 statements here. Okay, so let's create this truth table. When I create my truth table, I have a P and I have a Q, so I need a column for P and a column for Q, for sure. Now, looking inside the parentheses, what do you see? Tilde, right, Adam? Yes, I see a tilde Q, which I don't currently have, so I need it. I need a tilde Q because the inside of the parentheses has one. That's really just what it is. It's got one there, so I need one. All right, so then once I have that tilde Q, then I can do the entire set of the inside, right? Because I have every component of that represented already in column headers. So now I've got a P and tilde Q column. Got everything inside the parentheses. On the outside of the parentheses, I have a P, which I already have a column header for that one, right? So my last column will just be combining everything that the entire expression says. So we have P and tilde Q, whoops, VP. But the difference is this is not a truth value. This is a truth table, which means that I need all of the same representations that I had when I did the other ones. So you tell me, what does my P column look like? Right. True, true, false, false. What does my Q column look like? True, false, true, false. No other options. This is every combination of trues and falses between 2 items, okay? Tilde Q, though. What's tilde Q going to do? It negates Q, right? It negates Q. So it's going to do false, true, because it's exactly the opposite of what column Q said. So this is false, true, true. Now I'm going to consider this column and this column because it says I'm supposed to take P and tilde Q and join them with a and statement, right? This says and. So if I have true, false, is that true or false? That is false with an and statement. And statements are true when? When they're both true. That's the only time you get an and statement true. So my second row has TT, which means it's true. My third row, and I'm just looking at the ones that I highlighted in pink, my third row has FF, which is false. And my fourth row has FT, which is false again. Okay, I'm going to change the color of my highlighter now. We'll try that. Now I need to take the column that I just created, this one, and I need to join that with column P, because that's what this says right here, right? So join them with column P, but I'm joining them with the conjunction, or with the connective or, right? Or. So the first one says T, the second one in green says F, and T and F with an or is true. You just got to memorize these. We don't want to have to keep reiterating them every time. But then I've got T and T, which is also true. Then I've got F and F, which is false. And my last one is also an F and an F, which is false. I don't have to interpret. There is no answer to this. I did exactly what I was supposed to do, which was create a truth table. All right?